Awesome. So again, thank you everyone for joining us today for our Clean Energy Systems webinar. Before we get started, I did want to talk a little bit about the Polytechnic School. So we are one of 8 schools within the IRA Fulton Schools of Engineering. Our school does house more than 900 graduate students, and we offer hands-on system-oriented graduate education with strong industry connections and project-based learning. We are also known for our applied degrees that emphasize real world impact and career readiness. So, now jumping into clean energy, what that is, what it consists of, and some key takeaways. So, the MS Clean Energy Systems prepares students to tackle technical and environmental challenges of the 21st century using engineering design, analytics, and system thinking. So, some key focus areas within this program include renewable and clean energy technologies from solar, batteries to fuel cells, power electronics and zero emission systems, and cross disciplinary systems in engineering integration. Looking at our research and applied experience, this degree really emphasizes on hands-on lab and project work within its curriculum. Once again, as mentioned in that previous slide, cross-disciplinary collaboration is also something that we really focus on. So your courses will consist of anything from electrical, mechanical to renewable energy. And students will also have an opportunity to work with faculty on cutting edge clean energy systems research. Zooming into the program structure, so this program is comprised of 30 credits. So most students can complete this program within 2 years, or they could also complete it in as little as 1 year or 2 semesters. So some of those core classes within the program consist of systems engineering, analysis, and quality control. So all students will take engineering analysis 1, statistics and quality control, and then principles of engineering. In addition to the core classes, students will also take electives, which will be tailored to clean energy technologies. So a really neat thing about this program is that students can actually customize the electives they want to take depending on their career interests. So if you want to do design, research, integration, you really have that flexibility to take on any electives that pique your area of interest. And faculty can also assist with helping you select electives to help you reach your overall career goals. And then students also have the option of choosing which culminating experience option they want to take. So within this program, there are 3 culminating experience options, which consist of a portfolio, an applied project, and a thesis. Turning the page over to internships, or also often referred to as CPT. So internships are not only a great opportunity to gain industry experience, but eligible internships are also applicable for academic credit. So if you earn an internship, you could definitely apply that towards your degree progression. So that will help those 30 credits that you take. International students become eligible for internship after 1 full academic year, and then domestic students become eligible for internship after 1 full semester. And internships can occur during really any time within the fall, spring, or summer terms. And then I wanted to highlight some internship opportunities that students can potentially see within clean energy. So there's energy systems research, energy data and analytics, data and modeling intern, just to name a few. ASU also offers career services, which is a really great department to help you through career exploration. So if you need help with your resume, if you want to prep for interview questions, if you want to know more about the job fairs or employer connections, career services is a really great resource that a lot of our graduate students take on as they prepare for those internships. I also wanted to highlight some specific internships that our MS Clean Energy students have participated in. So one of the first one is PV Insights. So this was a clean energy analytics company, which did result in a full-time employment opportunity for the student once they graduated. So that was a really good experience for them. Another one of that is Nova Source Power Services. So this was a utility scale solar PV operations and maintenance company. This student was a performance engineer intern, and they supported a global portfolio of 30 plus gigawatts, which is the largest worldwide. And this internship can potentially result in a full-time opportunity for the student once they complete their degree. And then the last one I wanted to highlight was from the LUT University in Finland. So this was an international research internship which focused on electrical vehicle battery technologies. So these are just a few. Of course, there are more to come by, but these are some of the highlights from our students. And then I also wanted to highlight some of our campus labs that focus on clean energy and other systems. So we have the Dynamic Systems and Control Laboratory, the Laboratory for Energy and Power Solutions, also known as LEAPS, Power Electronics and Energy Conversion Laboratory, and then the Power Electronics and Control Conversion Laboratory, also known as the Peace Lab. So if you ever want to know more information about what each of these specific laboratories look at or the faculty that oversee it, you could click on these links and it'll give you more information. I'm sure Dr. Kanan can also give some more insight to our labs and how students can get involved. And then really quickly, I wanted to plug in the graduate advising office and just kind of explain who we are and what we do. So we are full-time professional advisors, and we're really here to advocate for students, provide them with campus resources, and really assist them towards the completion of their degree. So you could contact us at polygrad@asu.edu, or you could also give us a phone call at 480-727-1874. Our office is open Monday to Friday from 8 to 5. So if you do want to schedule an appointment with any one of our advisors that you see here on a screen, you are more than welcome to do so. We could talk about the application process, next steps for clean energy, or if you had any specific questions that we may not have covered, feel free to schedule an appointment with us. And that is it from graduate advising.
So I have a couple of slides here, but just to introduce about myself, I graduated in 1990 with my PhD degree, mostly working on batteries and fuel cells. So I have been doing almost similar aspects for large scale applications in the past almost 35 years. I started in ASU after 15 years of industry experience in ASU in 2005. I started as associate professor and then full professor from 2014. Right. So this is very good information as to why we need these clean energy systems. If you can see the numbers on the left top, when somebody drives a regular car, 1 year, they actually release about 5 metric tons of carbon dioxide. That's a global warming gas. And this is per car, so about 5 tons per car per year. And there are about 1.6 billion number of cars on the world. So you can imagine, 1.6 billion times 5 tons. That's the amount of CO2 getting into the atmosphere every year. So in that context, especially, this is only from the automobiles, right? So we can actually offset if we can at least, remove those dirty or, CO2 emitting vehicles from the road. So that's again, one of the reasons why we wanted to also work majorly on EVs. But when we talk about electricity generation, do we still want to go with the one you see at the left bottom? This is a typical coal-fired power station. This could be for about 1,500 to 2,000 megawatt power. It's not a real huge, but it's not just the CO2; it's also dirt, right? But if you look at the ones on the right-hand side, we have resources, whether it is, smaller wind turbines or solar PV, then, associated with that for removing the dirty automobiles is to make the cars electric, zero emitting vehicles. But if you ask me where the electricity come from, then you can actually have solar PV or wind or maybe even hydrogen. Whenever we get electricity through renewable means, that's from wind and also solar PV, we can split water, produce the hydrogen and oxygen, release the oxygen into the atmosphere, store the hydrogen, and use the hydrogen whenever we need in the vehicle using fuel cells. That again, just a big cycle of generating just water and electricity. Absolutely no pollution with the hydrogen-based fuel cells. We do that. So if we come back to like Arizona, there's a good ecosystem for the electric vehicles and also zero emission. So you can see in the US map where Arizona is located, there's a good working relationship between private sectors, the policymakers, the government, academia, three different universities as part of the Arizona system, Arizona State University, University of Arizona, and Northern Arizona University, and also the transportation community, so all the users. So in addition, even though they all come together on a regular basis to come up with the policies and also resource identifying resources required for effecting that, there's also an institute which is called the Institute of Advanced Mobility. This institute is sort of a virtual, but most of the participants are from the Arizona State University. You can see there are other institutions, other organizations as part of this program, which is mainly, driving the ecosystem, especially for the electric vehicle move. And especially when we talk about electric vehicle, we cannot rule out this Waymo One's autonomous electric taxis. You can see that Arizona is the largest operational area in the entire country. And ASU is somewhere here, in almost in the mid of this bluish map within Phoenix metropolitan area. So you can take Waymo to go to any place, whether you go to shopping or, to visit friends. It's very convenient and it's very safe. Now, from almost mid-November onwards, these vehicles also drive in the highways and freeways. And if you want to really look at the major organizations and players within the EV ecosystem, there are big companies, including LG Energy Solutions, which is from South Korea. They have invested about $6 billion, and the plant is almost ready with 90% construction completed, and they're going to start the manufacturing. This is going to be the largest electric vehicle battery manufacturing. So that's going to be here, which is just a couple of miles from the Polytechnic campus. And LG has been working with the ASU in terms of even establishing a energy center or battery energy center within the ASU's innovation space, especially in the Polytechnic campus. So Polytechnic campus is, very nicely located in the east part of Mesa, where space is not a restriction. So, a lot of companies are coming into the area where, ASU Polytechnic is located, and also hydrogen based. Hydrogen is also going to be exploited as a fuel for smaller planes, including urban air mobility, which is going to be operational by Boeing, and Honeywell is actually going to use the hydrogen. Boeing is going to use the battery. And there's another company called Evolution. So that's a big cobalt processing company located about 150 miles from Phoenix area within Arizona. And then lithium recycling. So, when the batteries come out, so we need to have a cleaner cycle or a sustainable way to handle battery and battery materials, and also recover and recycle materials. So there's a big company, which is, again, one of the largest battery recycling companies. So this is also located about a mile from Polytechnic campus. So many organizations which are related to electric vehicles, including Nikola, which is a fuel cell operator, and also the Lucid electric vehicle company. Lucid manufactures electric cars, which is the topmost of topmost in electric vehicles in the country. So that's being made here in Arizona, which is about 40 miles from Phoenix area or our campus. And I think I did see in one slide, Emil showed that ASU was established in 1885. So the university is relatively old, well established. With you can see some numbers here, right? So 194,000 plus in the 24, 25. And undergraduate students are 150,000, graduate students are 43,000. This is the entire ASU. And you can see, there are students from 165 plus countries. So this is a real, mix of culture, and you as a student, you learn a lot, not just the topical areas. So I don't know to go through because Emil, you did say we are 8 schools. I think a 9th school is being added as a medical engineering school. That will be from this fall semester. But again, we are one of the largest schools within the Fulton Schools of Engineering. So the Fulton Schools of Engineering, established in 1954, has almost 500 tenure track faculty and probably about another 400 plus faculty from industry. That's one of the biggest thing in the ASU. ASU is very well connected with the local or industry, which is connected to various engineering disciplines. And the entire engineering schools have more than 35,000 students. Both includes, undergraduate and graduate students. So our school, you can see the list, so you don't have to read through now, but we have multiple programs ranging from clean energy systems, engineering education, human systems engineering, and also aeronautical engineering, and obviously the what is that? ERM? Yeah, ERM. That is environmental resource management, to name few. So there are much more programs. So you may or may not know about the location of where we are located. So, the Tempe campus, so that's a Phoenix downtown area. Phoenix is now very well connected with international destinations. And now they, because of the Taiwan Semiconductor Manufacturing Company, TSMC, which is actually almost in operation with more than $60 billion investment, which is, again, that's part of this area, which is on the northwest part of Phoenix. And ASU has campuses, in Tempe. That's the largest campus. So one in Tempe, one in Phoenix, another one in Glendale, and our campus is in the east side of the town, which is in Mesa. So that's appropriately named as ASU Polytechnic Campus. That's because of the interdisciplinary nature of all the programs, including advanced manufacturing. So whether you talk about robotics or additive manufacturing or energy applications, so we house the largest number of faculty within the schools related to clean energy systems, manufacturing, and also all the way to the application areas. And our students stay in the Polycampus, go to Tempe, or stay in Tempe, come to Polycampus, because there are I think most of the times double decker buses, air conditioned, playing between the campuses like every 15 minutes from probably about around 5 to 10 o'clock every day. So the Polytechnic campus, this is a vast campus. So because, as I mentioned, this place has no restrictions in the space, and we are probably spread in more than 100 plus acres, and the campus still has 300 plus acres of land. So our director is Professor Kurt Patterson, and you can actually see all our faculty here. So Nate Johnson, Professor Mani, myself, Professor Malik, Dr. Zhu, Dr. Shao, Dr. Mayas, Dr. Chen, Dr. Guo, Dr. Suo, Dr. Kufar, and our director. And we are in the process of adding one more this academic year on the energy modeling. So all these faculty are into energy systems, and we are all in the same school. And ASU as a whole probably has more than 50 plus faculty working on various aspects of energy systems, but again, distributed among various 8 or other schools. But in our school, we built this, kind of a good setup with, all the faculty in one place. That's how we could establish undergraduate, masters, and also PhD programs in the clean energy systems. The areas are again, Emil, you did mention about the areas, but again, we conduct research on the energy and power solutions. When we talk about battery, it's a energy. When we talk about solar PV or fuel cell, it's a power. So we work on both. So we work on the smart energy materials or subsystems or full system level, but then we go all the way to the application areas. As you can see in the top, it says microgrid controls and off-grid solutions. So our faculty go from fundamental all the way to the applied level of research. And solar PV, I don't know how many acres of land for even outdoor testing and evaluation of solar PV modules in actual area. So Phoenix is probably the world capital of the solar because of the sun. We get probably about 340 sunny days in a year, meaning you can generate electricity almost literally every day. And power electronics, right? So without power electronics, we cannot do anything, whether it is in the renewable energy systems or distributed energy systems. So for even residential solar PV or smaller wind turbines or electric vehicles, whether it's onboard electric chargers or level 2 or level 3 chargers, you name any integration, system integration and control, power electronics is the key element. So we have 2 faculty conducting research in the power electronics area, and dynamic systems and controls. So mainly about system performance when the actual product is in use, not in simulated conditions. So this is how I think ASU Polytechnic campus probably has a uniqueness, because we conduct research in the real life situation. Whether one of our faculty, especially Suo, he works with a local city in terms of understanding and designing and developing ecosystem for the traffic signaling, because the roads have to become very smart, right? So one of our faculty has a vehicle, you would see in one of my slides, that's a fully autonomous Ford Mach-E electric car. So that's a smart mobility. We work on batteries, small scale batteries, all the way up to maybe 10 kilowatt hour large scale battery system for electric car and fuel cells. You see this translation and deployment. This is probably the signature of Arizona State University. We talk about use-inspired research. Whatever is being done in the university is always based on the demand from the general community, right? So if it is not useful for the people, there's no point in conducting research. Now, ASU also talks about principled innovation, meaning when we conduct research, the ethical aspects are also brought into the research lab. So principled innovation and also use-inspired research, these are all the main concepts. Integrated into the ASU's research system. So if you had already clicked that QR code, you would have already seen this page, but otherwise this is what you would see. So the goal is mainly to design, develop systems for operation, maintenance, or conducting reliability aspects related to various aspects of the energy systems. That's a major focus of the program. So I think Emil, you did mention some courses, but I have listed these courses, and the first 3 are the core courses, which are on the little more mathematical modeling of the energy systems and statistical process control for process energy systems manufacturing is a very important one. So I teach that because I did work in Exide battery company in India for about 9 years, doing mostly process control. Then one of our faculty teaches systems engineering principles. So that's mostly with the electric vehicle platform as a tool for the entire course. And other courses are again, you can see applied PV, alternative energy systems, batteries and electric vehicle technologies, connected and automated vehicles, reliability and standards, microgrid, power electronics, vehicle dynamics and controls. All these courses are being offered by our own faculty, and all the courses do involve 20 to 30% of the lab component. Again, in the polytechnic setting, students do understand with hands-on. So, 70% in the lab, about 30% in the 70% in the classroom and 30% in the lab. And also, almost all the courses would also bring in experts from local industry, and sometimes the faculty also take the students to the companies to get first-hand view of what is going on in a real life manufacturing. So that's PhD systems, but again, I think these slides can be shared, so I'm not going to talk about the PhD program, but students coming here can also get into the PhD program as they wish. There's a few courses here on the PhD. So as I mentioned in the beginning, we also have the undergraduate program, which was approved in the last fall, so which is going to take off probably next semester. So this is from my lab, so mainly on battery research and fuel cell research. So let me see if I have a battery picture. I don't think I have a battery picture, but this is a battery test system. So you can see the battery with the high current. So the battery is like a 6.85 kilowatt hour. So a typical electric vehicle will have about a 60 to 70 kilowatt hour. So this battery is like a 1/10 of what a typical electric vehicle will have in its as a EV or for the energy use. And we conduct research on electric vehicle battery thermal management. So battery temperature cannot be allowed to go above 50 or 55 degrees Celsius. So if you see the graph on the right hand side, the ones you see in red, that's with our unique materials, which is a phase change material, where the temperature is always lower than 50 degrees Celsius. Whereas if you do not use any thermal management materials, obviously the battery temperature goes close to 60. If you run the battery around 60 degree for a longer period of time, that's when the battery gets into thermal runaway. When the thermal runaway happens, the battery gets into probably explosion level. So you would have seen electric vehicles sometimes if there are any accidents or unwanted maybe issues. So that's when the battery will jump into those thermal runaway situations. And once the battery gets to that level, there's no way one can stop. So battery will start burning until everything burns. But our research is mainly on isolating battery materials when the battery temperature goes to a certain level, so that whatever happens is somehow retained or controlled within the same space without propagating to other areas. So the thermal runaway can be in a controlled manner. The ones you see at the bottom, this is a fuel cell where you feed hydrogen and it takes air or actually oxygen from atmospheric air to produce water and electricity. So again, we work on nanomaterials as a catalyst or catalyst support materials, but the fuel cell is mainly to operate any electric load, including maybe urban air mobility planes or electric cars with fuel cell systems using hydrogen. So we also have an electric vehicle training system, which is also being used heavily by most of our graduate courses. So this is a real Tesla Model 3 brand new electric car. So the vehicle is actually inside the building, but that's because it's being used for training the thermal systems or electrical system or electrical operation, all the power electronics components, including electric motors or EV powertrain. But again, the battery configuration is available, but there's no battery that you can drive the vehicle outside. But the vehicle still connects to Tesla. When we turn on, we can actually connect to Tesla and then operate or simulate all the operational conditions and monitor the battery's state of charge, state of health. You can actually set the vehicle to cruise, normal cruising at a particular speed, monitor the state of charge of the battery. You can set the temperature to sub-zero temperature or warmer temperature, and you can monitor the battery's available range, driving range, depending on the ambient temperature. When the battery or when the vehicle is exposed to say -20, -30 degrees Celsius, there may be like a 30 to 40% range reduction. You can actually study everything in this vehicle because you can set the ambient temperature to sub-zero. Similarly, when the ambient temperature is very high, say above 40 degree or 45 degrees Celsius, vehicle has to cool the battery and also cool the cabin. So entire energy comes from the same electric vehicle battery, which is located at the bottom of the vehicle under the seats. So in other words, energy will also be used for auxiliary applications for vehicle cooling and also to keep the battery under particular temperature. So to that extent, driving range will also be shortened when the ambient temperature is higher. So we study everything and also include or incorporate into the courses. And one of our faculty is actually making the system operational. This is one of the largest, like a lithium deposition system. Probably, I don't think ASU has this, but it's being commissioned this week by a Korean company, where you can actually make a pouch cell with a lithium metal. So you can have a micron level thickness for the electrode, highly uniform, and we can study the battery. It's being used to, it'll be used only for all solid state battery. So when I talked about electric vehicle with the lithium ion battery getting into flame, when the battery electrode materials are all solid and the electrolyte is also solid, nothing happens if there is an accident, or there's no limit for the battery to be under 100 degrees Celsius or 150 degrees Celsius. So battery will be very stable. You can go to high speed with a high discharge rate, or you can also charge the battery quickly in about 10 minutes. So for that, you need to have the battery in all solid state. So that's going to be the research. We have other faculty, as I mentioned, our one of our faculty, John Fung, he has this electric car. So this is again, indoor and outdoor research. So this vehicle is sometimes, driving on its own in the campus on its, 100% autonomous. We have a big group of people with a PhD and master students conducting research in this autonomous driving vehicle connectivity and mostly smart mobilities. We have other faculty who also works on the electric vehicle and also swarms of smaller vehicles. So mainly on the dynamic aspects of the electric car. You can see smaller vehicles. I think he has probably about 50, 60 of them. You can conduct research by putting them in one place under the roof. They run without hitting each other, meaning vehicle to vehicle, or vehicles are interconnected or connected and autonomous vehicle research. So this is a sort of homemade electric vehicle by Dr. Yan, where the important one to know here is this vehicle has a in-wheel hub motors, meaning the vehicle has 4 different electric motors and the wheels are directly mounted to the electric motor, meaning the vehicle does not have any transmission. So no transmission loss. Individual wheel can be controlled and operated from the central control. And that's another vehicle which is a Jeep Cherokee. So that vehicle is being converted to electric car for research. Another one, vehicle dynamics. So he's also in the same EV program. So Dr. Abdul also had a big program on the Eco Car, which is a student-centric program with the United States, Department of Energy and GM funded a program for 4 years. So this is the faculty who conducts the research with local city Chandler on the real life traffic system, or conducting smarter traffic system for local cities. So PhD students and master students do go to the actual place for collecting data or implementing prototypes with the cities. We have other faculty. He probably is the one with the longest time in the Poly campus. So Professor Mani started in 99 in the Poly campus. So he has been here for a very long time. He has a lab which conducts real life PV modules, performance and reliability, and all kinds of testing with dropping snow or ice balls, conducting research by placing modules at low temperature, high temperature, low humidity, high humidity to simulate operational conditions. And then, soiling, or, putting modules above water and all those things. Various aspects of solar PV research. So the lab has probably about 3 acres of land for outdoor research. Other professor, so he works mostly on power electronics, as I mentioned. The purpose is to integrate battery or PV or even, wind turbine systems for transportation applications, or, integrating grid, microgrid, renewable energy integration, all these power electronics aspects. So he has a big group of PhD students, and he's one of our star faculty in bringing in local companies and also bringing in government funding. So all our faculty have working relationship with the local companies, and I think all of our faculty also have funding from local industry, whether it is, like a Intel or Microchip. Again, Phoenix is very good in terms of, locating companies related to aerospace engineering. Now with all the EV, but again, aerospace engineering, composite materials, or, all other auxiliary materials. And now TSMC and Intel. So Intel has four fabs. I think Intel started probably like 30 years ago in Phoenix area. So power electronics, our other faculty, so he works mostly on the solid state transformer, magnetic integration, and mostly with the semiconductor power module, like a flat transformer. So various applications require that all these electronics are very compact, not very bulky, so it has to be lighter and smaller. But the important thing is, like a battery, that's also thermal management in the power electronics. So our faculty also conduct thermal management for power electronics. So I don't know whether I'm the right person to talk about the requirements for clean energy systems admission requirements, but again, I'll briefly talk about here. So minimum requirement is a 3.0 cumulative GPA out of 4. But I think GRE is probably required, but I don't know whether it is. I think ASU waives the GRE requirement and also the TOEFL, as long as the undergraduate education is offered in English. Okay, so I think, so I think the important aspect I wanted to show here is, especially with these programs, right? So there's a range of salary, you can say around 100 K per year after students graduate from renewable energy program. So when I started in 2005, we had a master's degree in alternative energy technology. So we had been doing this renewable energy systems based master's degree program, but now it is more focused into EV and other areas also. but the companies hiring our faculty are mostly solar PV companies or any company related to energy systems and EV companies. So I thought of just showing this. So the students, you can see what they mentioned about our program. The one at the left top, Garikai, he was our first master student admitted in the fall 2024. He will be graduating in this, I think, end of this semester. And he actually did internship. Emil also talked about in a local PV company. Then another student, Ruth, she started last fall. She's in the second semester. And then we have another guy, these are only about 5 out of, I think we had 14 or 15 students started last fall. This is just a handful of people to just show what they talk about our program. We also had another guy through Fulbright program from Germany. So he planned to be here for 1 year, but looks like he wanted to maybe join for our PhD program. So maybe he has time to decide. Then another girl, Linda. So she also started last year. She was actually, is also connected to the UN sustainability program. When she was here last fall, she did participate in the UN meeting last year in New York. So I think Emil already talked about. So these students, right? So especially the number 2, Chandana, she was a master's student in University of Windsor in Canada, but she was in touch with me, and then she wanted to move to Arizona, especially to join our master's program. So she actually started last January, and then she did the internship in PV Insight company. Now she graduated at the end of last semester. That's in December. She graduated on, I think the graduation program was probably on December 15th, and she started her job in Dallas, Texas, next day, very next day. And she works in the same company where she did her internship. And Helen was the student who did her internship at LUT University in Finland. And so, sorry, I didn't put Emil, your detail, but I put Megan's contact info. But then, so these two are our recruitment staff located in India. All right, thank you very much.